Good evening, my dear student. Welcome to everyone in my YouTube classes. Today we'll discuss or we'll learn a new one interesting topic from the chapter of chemical bonding of class 11. Okay, so today our topic is molecular orbital theory. Okay, MOT. Okay, my dear students, see, MOT means this is the like as a molecule. Okay, what is molecule? We know the two atoms or more than two atoms are combined to make a molecule. Similarly, in case of molecular orbital, it is similar like as an atom. That is, here orbitals will combine. That is, two atomic orbitals are combined. Actually, there are two atomic orbitals. So one is bonding, another is called anti-bonding. Okay, that is two atomic orbitals. Sorry, there are two atomic orbitals. Suppose we consider one atomic orbital as psi1 and another atomic orbital is psi2. Okay, we consider two atomic orbitals. These two atomic orbitals are combined to make molecular orbital, and they make two molecular orbitals. Okay, if this psi1 and psi2 are added to each other, they can make bonding molecular orbital. Okay, and if these psi1 and psi2 are subtract, they make anti-bonding molecular orbital. Understand? One is bonding, another is anti-bonding. Okay, bonding is that is in favor of bond formations, or anti-bonding is the to resist a bond formation. That is, if two atomic orbitals are made bond, that is in favor of bond, that is called bonding. That is, they have attraction. Okay, they are attracted to each other. If they have a repulsion, they did not attract to each other, they have a repulsive forces, that is called anti-bonding molecular orbital. Understand? So similarly, the psi1 plus psi2 is bonding, and psi1 minus psi2 is antibonding. Okay, and the energy of these bonding molecular orbitals and antibonding molecular orbitals, the energy of the bonding is less than antibonding. Why? See, if psi1 and psi2 are combined, they make the bonding. Okay, that is, they are in favor of bond formation, they have no repulsive forces, they are attracted to each other. So if we consider these two atomic orbitals, psi1 and psi2, okay, these psi1 and psi2 are combined to make two molecular orbitals. One is called bonding, another is anti-bonding. Okay, so see, what is bonding? The bonding is the psi1 plus psi2. Anti-bonding is the psi1 minus psi2. Okay, if we go for the energy level, see, the energy is increases from bottom to top. That is, the energy of the anti-bonding is more than that of bonding. It's very simple thing. So what we have learned? Molecular orbital means the combination of the two atomic orbitals, and two atomic orbitals combined to make two molecular orbitals. One is bonding, and anti-bonding. Bonding is addition, and anti-bonding is subtraction of atomic orbitals. Okay, so you know atomic orbital. Suppose S atomic orbital. Suppose two atomic orbital S plus S. We know S plus S make only sigma bond. Okay, so these two atomic orbitals, they can make sigma as well as they can make sigma star. What is the sigma star? Sigma star means they can make anti-bonding also. Okay. Similarly, suppose you have a two p orbitals. Suppose one p plus another p. We know p can make sigma, then sigma star, pi, and pi star. Okay, so that is, they can make sigma, sigma star, pi, pi star. Now, question is that when they make sigma, when they make pi. Okay, if the two atomic orbitals, they are overlapped in terms of their axis, like that, at two are overlapping, that is called sigma. If they are cyclical overlapping, they are called pi. Understand? So p orbitals, they have a ability to make sigma as well as pi. Why they make sigma and they make pi? See, if two atomic two p orbitals, suppose one p orbitals is like that, another p orbitals, I have another p orbitals. See, these two p orbitals, they are combined to make sigma bond. How they make sigma bond? This is actually sigma bond. Okay, here see, Here the overlapping is head-to-head overlapping. That's why you can calculate sigma. Okay. Similarly, these two atomic orbitals, they can overlap side to side. That is like that, side to side overlapping. They can make pi bond here. The overlapping is C, side to side overlapping, and we can tell it is a pi bond. Understand? So p orbitals having a capacity to make both sigma as well as pi. Understand? Now question is that which p orbital makes sigma and which p orbital make pi. Actually, the p orbital which is present in the nuclear axis, it makes sigma. Okay, so we considered z axis is a internuclear axis, that is z make the sigma and x and y make pi. Understand? Very simple thing, x and y make pi. Okay, because why x and y make? Because x, see, there are two atomic suppose p orbital, p having three orbital, like as a see, this is z axis. Okay, then suppose x axis, y axis. Suppose it is z, it is x, it is y. So another one, suppose it is z, it is x, it is y. See, when they are closer to each other, y and y are parallel to each other, x and x are parallel to each other, z and z are touched, head to head overlap to each other. That is z to make sigma bond. So we can tell pz plus pz make sigma bond, or px plus py makes pi bond. Sorry, not px plus px, px plus px and py plus py make pi bond also. Okay, they can, that is they can make sigma sigma star, they can make pi pi star, they can make pi pi star. Understand? Clear? So now when they make sigma and when they make pi, that is when they are attached head-to-head overlapping, that is the overlappings will be head to head, but still they make sigma, and other cases they make pi, that is x and y make pi and z make sigma. Understand? Clear? Okay. So now if we show the pi orbital, that is pi bonding and anti-bonding, see the diagram. What is the diagram? Suppose we have a p orbital, this is another one p orbital, plus I have wrote another p orbital. See, there are two p orbital I have wrote, and the charge of the orbitals is, suppose these are plus plus, these are minus minus. Okay, you know the charge of the plus and minus. Okay, and then now they are overlap to each other. See, they are overlap to each other, and their overlapping is like that, because in this case they are attract to each other. Understand? Here it is plus plus, it is minus minus. That is they make bonding. Bonding is the addition, they are added to each other. Okay, that is bonding MO. And another one is C, another one is the anti-bonding MO. When they make anti-bonding MO, suppose this p orbital minus another p orbital, we have a two p orbitals, and this is plus minus minus plus. That case they make, see, here the charge is plus minus minus plus, they are repulsed to each other. Understand? So this is called anti-bonding. Anti-bonding. Understand? So what we have learned? The atomic orbitals are combined to make two molecular orbital. One is called bonding, another is called anti-bonding. Bonding is the addition, that is in favor of bond formation. Anti-bonding is the that is resist to bond formation, and energy of the bonding is less than anti-bonding, because in bonding they are added to each other, in anti-bonding they are repulsed to each other. Understand? Clear? So this is the total actual theory of the molecular orbital. Now we go for example. Okay, then how we write the molecular electronic configurations for any molecules we learn now. Okay, this topic. So see, I think you understand this part is very easy. Okay, now we go for the example. Suppose, see, I'm taking one example. The example is okay, I take O2 molecule. Tell me how O2 will form. No doubt, one oxygen atoms and other oxygen atoms are combined to make O2 molecule. Okay, you know O2 in oxygen atoms. What is that electronic configurations of oxygen atom? It is 1s2, 1s2, 2s2, 2s2, 54, 54. Listen now. Now see, when these two atomic orbitals, these two atoms are combined, these atomic orbitals are also combined. These atomic orbitals are also combined. Understand? And in this case, when 1s and 1s are combined to each other, we know S plus S make which bond? S plus S make sigma bond, and sigma star, that is sigma bonding and rebonding. P can make sigma as well as pi both. So when here we have only S orbital, so it ability to make only sigma or sigma antibonding. Understand? So now see the configurations of O2 molecule. What is the O2 molecule configuration? Sigma 1s, sigma star 1s. Actually, the energy of the antibonding is more than that of bonding. And see, the star indicate that the antibonding. Star indicate the antibonding. Understand? Star indicate the antibonding. Or without star, that is called bonding. The energy of the bonding is less than antibonding. That's why the sigma star 1s having more energy than that of the sigma 1s. Okay. Then go for the 2s second orbitals. These second orbitals make C 2s and 2s. So it can make also sigma and sigma star. That is sigma 2s and then sigma star 2s. Yes or no? Because the energy of the sigma star 2s no doubt is more than that of sigma 2s. Okay, because it is antibonding. Then we go for P. Okay, see, if there are two we need to remember these two things. One is if the system is P1 to P3 system, that is as first pi bond will form, after that sigma bond. Okay, because if it is up to half filled or less than half filled orbital, that is the ability to formations of pi is more than that of sigma, so and the energy of the pi is less than sigma. Okay, you remember it. And if it is P4 to P6 system, that is a sigma will first form, then pi will form. Understand? Okay. So here you see what is the configurations. Our configurations is here. It is P4 system, 2P4. You see that this is 2P4. So this is from this set. Okay. So from this set means which one will first form? Sigma will first form. Okay. You can easily understand a very easy see. Sigma will first form, and who makes sigma? Who makes sigma? We know the PZ makes sigma and PX and PY make pi. Okay. So if we go for the PZ, that is sigma to PZ, then pi to PX equal to pi to PY, and after that pi star to Px equal to pi star to Py, and ultimately last sigma star to Pz. Okay, this is the configuration. See here in the p orbital, there are how many orbitals in the p? There are 3 orbitals. Suppose Px, Py, Pz. There are Px, Py, Pz. Total how much? Total 6 orbitals. Count how much? 1, 2, 3, 4, 5, 6. Okay. There is 6 p orbitals combined to make 6 molecular orbitals. And out of the 6, 3 are bonding, 3 are anti-bonding, and out of the 3 bonding, 1 is sigma and another 2 is pi. Okay. Similarly in anti-bonding also same. Okay. Clear? Understand? This is very simple process. How we write the electronic configuration. Okay. Now we have to write we have to put the election. Okay. Tell me in the oxygen atoms how many electrons are there? In the sulfur 1s there are 2, 4, 6, 2, 4 and 8. That is oxygen 8 to the 16 electrons. 16 atoms, we have to put maximum 2 electrons in each orbital, maximum 2, and you can put here 1 electrons, but maximum 2, not more than 2. Okay, so 2, 4, 6, 8, 10, 12, 14, and then 15, 16. Now question is that why you have write 1 1. Okay, actually you know the from the structure of atom, that is what is the theory? The theory is in multiplicity law, the electron first enter one electrons. After that, the remaining electrons will be made as a paired electrons, okay, or a paired of electrons. Understand? So here there are one electrons we have extra, so we can put one electrons. And now count total number of electrons is equal to 16. Understand? I think it is very easy. I will write the configurations. Okay, now I go for another example. You will get also will be clear it from the example. Next example, suppose we go for the fluorine, that is F2 molecule. See, F2 means 1s2, 2s2, 55, 1s2, 2s2, 55. That is same. Understand? Means here similarly the 1s and 1s are combined, 2s and 2s are combined, 2p and 2p are combined to make the molecular orbital. Understand? Okay, better understand. See, very easy. Okay, chemistry is very easy. Okay, now see, then 1s and 1s are combined to make what? Which one? Sigma 1s, then sigma star 1s, sigma 2s, sigma star 2s, then which one comes first? Sigma 2pz, then pi 2px equal to pi 2py, then pi star 2px equal to pi star 2py, and ultimately last one is sigma star 2pz. Now we can put this symbol indicate that the energy is increasing from sigma 1s to sigma star 2pz. Okay. Now we have to put the electron. How many electrons in the fluorine? 9 electrons. So 9 to the how much? 18. Count 2 electrons, 2 electrons, 2 electrons. How much? 6, 8, 10, 12, 14, 16, 18. Understand? There are 18 electrons. Now we can put 2 by 2 to 2 electrons, and up to total number of electrons will be how much? Up to 18. It's very easy. How to do the configurations of MO, that is the atomic orbitals combined to make molecular orbitals. You have to remember this. This is the most important term, that is you have to remember, and this is another one, which one makes sigma and which one is make pi, and then it is very easy, but you have to put only in the number of electrons by count the number of electrons and put it. Okay, now we go for the another one example. Okay, see, if you do more number of example, you can easily understand. Okay, the theory is very easy, but the important thing is the application. Okay, because in the NEET and JEE exam, the questions will come actually as a application type question. Okay, you know everyone. Now we go for the one. Suppose nitrogen atom from anti molecule. Okay, see, nitrogen atom is 1s2, 2s2, 2p3. Nitrogen atom 1s2, 2s2, 2p3. Okay, understand? See, here this 1s, and 1s are combined, 2s combined, 2p combined. So configurations will be same like, but the difference is that here see, it is P3 system, and the remaining first the last two one we have done last two example, there are P4 and P5 system, that is there came from this series, but now this one came from this series, that is from P1 to P3 system, that is first pi will form, after that sigma will form. Understand? To see the configurations I will write very easy. That is first sigma 1s, after that sigma star 1s, then sigma 2s, then sigma star 2s. Now first, which one first form? Pi. Pi to px equal to pi to py, then sigma to pz. Understand? Then pi star to px equal to pi star to py, and after that sigma star to pz. I think everyone understand, it is very simple. Now we have to put the only the symbol. Okay, whose symbol? The symbol is less than symbol, that is indicate that the energy is rising. Okay, now then the energy of rising, and now we have to count the electron. How many electrons we have? See, there are 2 nitrogen atoms. One of nitrogen atom contains 7 electrons, and 2 nitrogen atom contains how much? The number of electrons should be 14. So count up to 14. 2, 4, 6, 8, 10, 12, 14. Done. Understand? Very easy. We have to put only the number of electrons in the configuration. Okay, if it is less than 3 P3 system, it follows this order. If it is more than 10 P3 system, it follows this order. And what is the difference between them? See, I'm showing in the one slide the differences, and on another color, see that these two are exchange their position only, or other thing is same. Understand? These two are change their position. Sigma to pz, pi to px, and pi to pi. They are exchange their position when it will be more than P3 system, or otherwise when it is less than P3 system. It is very easy. I think everyone are understand. Okay, clear? So this is the actually MO configurations and the MO theory of biatomic molecule or diatomic molecules having same nucleus. Okay, here the nucleus is same, so it is called as a diatomic homonuclear molecules. Understand? Okay. Now, actually, from that one or from that topic, the important term is the, what is the important term? Important term is the application based question. Okay, to lead to application based question, for the application based questions, we have to idea about one topic, that the name of the topic or the name of the term is bond order. Okay, one term called bond order. See, bond order. Bond order. What is bond order? What is bond order? Bond order is equal to number of bonding electron minus number of anti-bonding electron divided by 2. Now count for O2 molecule, how many bonding electrons are there? Count, see, there are 2, 4, 6, 8, 10. There are 10 minus anti-bonding electron, how much? Anti-bonding electron is 6. 10 minus 6 by 2 is equal to 4 by 2 equal to 2. So you can see that the bond order of oxygen equal to how much? 2. You can go for the fluorine atom. Bond order equal to number of bonding electron is similarly 2, 4, 6, 8, 10. 10 minus 8 divided by 2 equal to 1. For N2C, the number of electrons bonding is 10 minus 4 by 2 equal to 6. 6 by 2 equal to 3. Understand? That is the bond order we can easily calculate by number of bonding electron minus anti-bonding divided by 2. Okay, this is very simple for the calculations of the electrons. Okay, everyone understand? I will calculate the bond order. Now, question is, what is the requiredness of bond order? Okay, what is the requiredness? See the bond order, requiredness of bond order. Actually, bond order is very important for this topic. The application type, all the application type questions on this topic is depends on the bond order. So we have to know first some relations of bond order with other term. Okay, first see, bond order is proportional to 1 by bond length. If there are a more bond length, the bond order will be less, or bond order is more, the bond length is less. Understand? Similarly, if bond length is less, means bond is strong. Let me give you one example. See, suppose you have a chalk, one long chalk, one small chalk. Okay, which one you can divide? That is, which one you can break easily? No doubt, long chalk means the strength is minimum. Understand? But the small chalk you cannot divide. You can divide, but you have to put more amount of energy. That is, it is stronger. So if bond length is maximum, the bond strength will be minimum. Okay, so we can tell that if bond order is maximum, no doubt bond length is minimum. That is, bond strength is directly proportional. If bond strength is maximum, means need to more amount of energy to break the bond. That is, bond energy is also directly proportional to the bond order. And you will get in some cases the boundary is zero. Boundary zero means not exist. Suppose you can go for He2. He2 means sigma 1s2 sigma square 1s2. You can calculate the bond order. In this case, you can get the bond order equal to 2 minus 2 by 2 equal to 0. That is, this molecule cannot be exist. Okay, understand? If you get the bond order of a molecule is 0, this indicates the molecule cannot be exist. Okay, you have to remember this. These are four relation with bond order and other important term, because then in exam the questions will come from these four important terms. Okay, now questions is that what type of questions will come in the exam. Suppose my one question is out of N2 and O2, which is more stronger? First question. Okay, so how can we find it which is more stronger? See, if you go for the bond order of N2, bond order of N2, we get is 3. Okay, see, we get it 3. If you go for bond order of O2, we get it 2. Understand? So more bond order means more strength. See, bond order maximum means bond strength is maximum. So we can tell that N2 is more stronger than O2. Yes or no? This one type of question. Next is that similarly, suppose arrange the bond strength of the different molecules. Suppose one example, O2 plus, O2 minus, O2 minus. We have to arrange the bond order, bond length, bond strength, like that of questions. Okay, different questions will come. But here the important thing is that if you go for the oxygen atom or oxygen molecule, see the bond order we can get. The bond order is how much? Bond order is 10 minus 6 by 2 equal to 2. You can get bond order is 2. Now is for O2. If you go for O2 plus, see, in case of O2, where is O2? Yes, O2. See, in O2 the bonding electron is how much? 10. Anti-bonding is how much? 6. Okay, but if you go for O2 plus means 1 electron will be less. 1 electron will be less. That is 1 electron from the anti-bonding is less. Understand? Now see, the number of electrons in bonding does not change, but in anti-bonding 1 electron has decrease. Understand? So the number of electrons in the anti-bonding will be now 5. Yes or no? Will be now 5. In anti-bonding number of electrons will be now 5. Now we have to write bond equal to 10 minus 5 by 2 equal to how much? 2.5. Now we go for O2 minus. What is the bond order? Bonding electron 10 minus 7. You can see 1 electron should be extra, and it will be also enter in the where? In the pi orbital, because see, it will be 2 now when it is O2 minus. Understand? It will be 2 now when it is O2 minus. That is okay, in O2 minus by 2 equal to 1.5, and O2 2 minus bond order equal to how much? 10 minus 8 by 2 equal to 1. Understand? So see the order of the bond order. Bond order is O2 plus is maximum, then O2, then O2 minus, then O2 2 minus. Okay, this is the bond order. So if the questions will come, arrange their bond strength. The bond strength and bond order are directly proportional. That is, it follow the same order. O2 plus, O2, O2 minus, O2 minus. If the question is bond length, then it reverse order, that is O2 2 minus, sorry, O2 minus is maximum. Bond length, which one is maximum? O2 2 minus, then O2 minus, then O2, then O2 plus. O2 plus is maximum bond order, means minimum bond length. Understand? So these two questions will come in the exam. You have to arrange it. Similarly, you can this is you can done. Otherwise, you can now do. Suppose H2 plus H2 minus. This is one question. Second question, you can do N2 plus N2 minus and 2 minus. Okay, you can do it. Okay, these two questions you have to solve. Okay, and their order. After solve this two questions, you can text me. You can leave the message. Okay, this is your homework. Okay, now next one, another one important topic is there. There is called magnetic behavior. Magnetic, okay, character. What magnetic behavior? See how what is the called magnetic behavior? But magnetic character means if we put this molecule in the magnetic field, is there any effect or not? If they show any effect, this is called paramagnetic, and if they have no effect, it is called diamagnetic. Understand? Very simple. Now question is that how can we know is it paramagnetic or is it diamagnetic? And for that cases we have to know what is the order? Diamagnetic. Diamagnetic. Diamagnetic means if there are no unpaired electrons, no unpaired electrons, or another is the paramagnetic. Paramagnetic is unpaired electrons. There are unpaired electrons. Okay. So see, if you go for these three configuration, what I have done, suppose for O2. See, in the O2 there are last electrons is no doubt single electron. Single electron means this is what is called not paired, that is unpaired electrons are there. So O2 having two unpaired electrons. If you go for F2, there are no unpaired electrons. If you go for N2, see there are no unpaired electrons in the last shell. So this out of F2, N2 and O2, which is paramagnetic, and O2 is paramagnetic, and other two F2 and N2 is diamagnetic, because in F2 and N2 contains no unpaired electrons, whereas in O2 there are two unpaired electrons, so it can be paramagnetic. That is, the O2 will be paramagnetic. Understand? O2 is paramagnetic. Whereas this N2, F2, these are diamagnetic. Okay. Similarly, see another one. If you go for O2, O2 plus, O2 minus, O2 2 minus, see in O2 there are two unpaired electrons. O2 plus there will be one unpaired electrons. O2 how much? Two unpaired electrons. O2 plus how much? One unpaired electron. O2 minus how much? One unpaired electron. O2 2 minus, zero unpaired electron. O2 2 minus means there will be 18 electrons. See, O2 2 minus means this is the O2. This is O2 and two unpaired electrons extra. This will be 2 and this will be 2. Understand? So there are no unpaired electrons, and no unpaired electron means it is diamagnetic. So this the magnetic characters of O2, O2 plus and O2 2 minus, if we have to find that cases this is diamagnetic and all are three paramagnetics. Okay. Now what is the value and how can we calculate the value of the magnetic behavior? Magnetic behavior value, we can calculate the one formula mu equal to root over of n into n plus 2. Using this value we can calculate the value of magnetic moment, and the unit is Bohr magneton. Understand? The unit is Bohr magneton. Using this one we can calculate easily the magnetic behavior of any molecule. Suppose here O2, if you go for O2, then mu O2, that is, see how many electrons are there, 2 unpaired electrons, that is 2 plus 2 equal to root over of 8 equal to 2.83 Vm. Understand? So we can calculate easily the magnetic moment or magnetic behavior of a molecules using this formula. And see, one important thing is that if n equal to 1, the mu equal to 1.73. If n equal to 2, mu equal to 2.83. If n equal to 3, mu equal to 3.87. N equal to 4, mu equal to 4.89. N equal to 5, mu equal to 5.92 Vm. Okay, you have to remember this one. Then it will be very easy or helpful in exam hall. Okay, because we have to arrange it, their magnetic character. See here how many O2, in O2 how many unpaired electrons? 2. So the value will be 2.83. Here it will be 1.73. It is also 1.73 and it is 0. So you can easily arrange which one is more and which one is less. So here the which one is more negative moment? O2. Then O2 minus equal to O2 plus, and after that O2 2 minus, which will be 0. Understand? So easily we can easily calculate the bond order, bond strength, magnetic character, everything using this equation, that is this relationship. So it's very important. Okay, using these relations we can easily calculate the some this type of questions, approaching like these questions. And see, there are another important questions has come in the exam for last exam, that is ionization potential about the molecule. Okay, you know ionization potential. Ionization potential, what is the meaning? Ionization potential means suppose you have one atom. The atom saving, suppose this is the atom. The atom saving in the outermost shell, they no doubt they have the electrons. The amount of energy required to remove this electron, this is called the ionization potential. Okay, so if electron is more attracted by the nucleus, that is more amount of energy is required. Okay, clear? So if you go for the molecule, that case is how can we calculate? Suppose N2 and O2, which one has more IQ? Okay, in this case, see, if you go for O2, the outermost electrons of the O2, see here in outermost electrons of O2, you can see the electrons are present in anti-bonding molecular orbital. Okay, but if you go for N2, see the electrons are present in bonding molecular orbital. Okay, so you have to remove the last electron. That last electron means in O2 you have to remove electron from anti-bonding, and in case of N2 you have to remove electron from O2, from bonding molecular orbital. Understand? In case of O2 anti-bonding, and in case of N2 it is bonding molecular orbital, the last electrons. See, in case of bonding, no doubt they are, we know in bonding they have attract to each other. In anti-bonding they are repulsed to each other. So the removal of electron from the anti-bonding is very easy, because they are, in that case the electrons are not attracted to each other, they are repulsed to each other, so you can easily remove it. Whereas in case of bonding, they have an attraction between the two atomic orbitals, so the electron cannot be removed easily because they have an attraction, so more amount of energy is required. So we can tell that in case of O2 and N2, no doubt the ionization potentials of O2 is less, because the last electrons are present in where? In the anti-bonding molecular orbitals. Understand? So these are the total atomic molecular, not atomic, molecular orbital theory. I think everyone understand. Okay, and then last is that in the school exam or some exams, okay, you can get the structures also. That is they ask the questions, that is like as you draw the structure also. Okay, this is very easy structures. You can easily draw the structure. I'm showing you one structure and you can draw it easily. Okay, first you have to draw the energy. Okay, this is the energy. The energy will be rising. Okay, see, there are, suppose I'm going for O2 molecule. O2 means oxygen atom, 1s, 2s, 2p, this is 4, this is 2, this is 2. Another oxygen, 1s, 2, 2s2, 2p, 4. Okay, now see, there are 1s orbital, there are 1s orbital. Okay, this 1s orbital contains how many electrons? There are 2 electrons. In 1s2, 1s, 1s. There are 2 electrons. See, 1s2, 1s2. These 1s2 and 1s2 are combined to make bonding. That is, this is sigma 1s, sigma star 1s. These orbitals are called atomic orbital, and these two are called molecular. So see, in the molecular orbital, sigma 1s contains how many electrons? 2. There are contains 2 electrons. See, if we go for O2 molecule, then sigma 1s, sigma 1s2, sigma star also 1s2, then sigma 2s2, sigma star 2s2, because this 2s and 2s also combined. Okay, that is now 2s and 2s also combined. 2 electrons from 2s, another 2 electrons from 2s. Now these 2s orbitals also. Okay, see, this is sigma 2s, sigma star 2s. So in the sigma star, that is sigma 2s contains how many electrons? 2, 2, this 2, 2. Then go for the p. The p orbital, they have a 3 orbital. You know, and how many electrons are there? 4 electrons. 4 electrons, 1, 2, 3, 4, according to Kuhn-Marcus-Rule law. We can write 1 electron first, then electrons will be paired. Okay. Now, first we make what? Sigma. They make first sigma, then make pi. This is pi to px, pi to py. This is sigma to p z, and similarly they make what? Pi star to px, pi star to py, and after that last is the sigma star to pz. Understand? Now put the electron. How many electrons are there? There are 3, 4, 4, 8 electrons. Okay, that is 2, 4, 6, 7, 8. Okay, this is the MO configurations of O2 molecule. Understand? This is for O2 molecule. Now, if we go for F2 molecule, then 2 electrons will be extra. That is, this pi star to px and pi star to py will be 2, 2. If you go for N2 molecule, this pi to px and pi to py or sigma to pz exchange their position. That is, sigma to pz goes to upper portion, and pi to px and pi to py came to that is sigma to pz position. They are replaced their position only. Okay, because we know that in this case the energy of the pi to px will be less for N2 molecule or the atoms which having less than P3 system. Okay, clear? Understand? So this is the way to diagrammatically how do the that is MO diagrams of a molecules. This is the process. First do the electron configuration, then okay molecular orbital diagram. Understand? So whatever we have learned today, today you have learned MOT. What is MOT? Combinations of atomic orbitals. How many types of bonds will form? Two types. One is bonding, other than anti-bonding. Bonding is the addition, anti-bonding is the subtraction. Okay, clear? So anti-bonding means they are repulsed to each other. Bonding means they are added to each other, and then some diagrams and some application type of questions we have done. Understand? Okay. Thank you for everyone to watch this video. Okay, and I'll make a new next video for another one interesting topic. Okay, thank you.